But as we all know, it's not always sunny and it's not always windy. So you've got factories that want to run 24 hours a day and they have a constant energy demand. And then we've got these renewables that are going to just be going up and down all the time. It's a rock aluminium composite, which is a mouthful. So we call it Warmstone. We make big, heavy blocks of this material and we heat them up so that they're very hot using the electricity from the wind and the solar. These are rocks that we can dig out of the ground. And this is a metal called aluminium. Think of it as a very heavy Rocky Road cookie that we've made by cooking. And this is what we store the heat in. So we can take electricity when it's sunny and when it's windy. We can make this block really hot. And then when the factory that we want to supply heat to needs it, we get the heat from this block into the factory.
This is Bite Size Climate Tech, Season 2.
Hi, Lydia.
Hi, James. Welcome to the show.
Really nice to be on here. And I'm James MacNaghten. I'm the CEO of a company called Caldera.
I'm really happy that James is with us today. And he is an experienced CEO, entrepreneur, and a Cambridge University trained engineer with 15 years experience in energy research and development, over 25 years of experience in business. Usually either a co-inventor or sole inventor on a wide number of thermal energy storage patents that has 20 plus patent families, isn't it? But what's most important is that he built and still owns Cambridge's largest tourist business for over 10 years. So if you ever go to Cambridge and see those hunting things, it's owned by him.
Yeah, and just a little plug. This company's called Scudamores. You want to come to us.
What we are going to talk about today is a secret thing behind Caldera is this thing called Warmstone.
First of all, what's industrial heat? Is it important? Well, the answer is a quarter, so 25%, all the energy in the world is used by industry for heat. And when you walk into the supermarket, all of the foods will have been cooked with heat. All the drinks you buy in your pub will have been made using industrial heat. It covers things like cement, steel, glass making. It covers everything. And we've got to decarbonize it if we want to decarbonize our economy.
Yeah.
Now, at the moment, almost always this heat comes from burning fossil fuels. We've got to stop that. And we now have a chance to, because electricity from renewable, wind and solar, is cheaper than any other form of generation. But as we all know, it's not always sunny and it's not always windy. So you've got factories that want to run 24 hours a day and they have a constant energy demand. And then we've got these renewables that are going to just be going up and down all the time. How do we manage it? So we've come up with a material we call Warmstone. I'm going to talk a little bit about how we make it in a second. But basically, we heat this up using electricity when it's sunny and windy to high temperature. And we have pipes that run through the material. And so when your factory wants heat, we can put water through the pipes. We can produce high temperature heat for the different processes. And we can feed them 24 hours a day. So from their side, it's coming out. It's just constant. And we can just vary the energy we put into these blocks depending on what's available, whether it's windy or sunny. Now, if we want to talk about how we make this, it's a rock aluminium composite, which is a mouthful. So we call it Warmstone. And it's basically made from, these are rocks of volcanic rock. It's basalt, very common all around the world. And this is aluminium. It's really cheap. It's a really low grade recycled material. And this is made from old car engine blocks. Now, aluminium is a great material because you can recycle it again and again and again. It melts at quite a low temperature. So what we do is, it's a bit like cooking. We basically get the aluminium, put it in a container, heat it up so that it turns from a solid to a liquid. And when you see it, by the way, it looks silvery. It looks like a mirror. It's an amazing material. And at the same time, we take the rocks, heat the rocks up in an oven. And what we do is we pour the aluminium over these hot rocks. And actually between all the rocks, there are little holes. And you can see how the aluminium has flowed in and it's filled the holes. And we end up making a block of material because we let it go solid. And once it's solid, stays solid for the rest of its life. The aluminium, this has higher conductivity than steel. It's got stores much more heat than steel, but it's really, really cheap to make because the rocks act as this really cheap filler material, and we only need the very, very lowest grades of aluminium. So we end up with making these blocks sort of 2 tons at a time. They're really easy for us to make, and it ends up with a very, very simple solution for customers because there's nothing that can go wrong with this. There's no chemicals here. It can't catch fire. It's not corrosive. And at the end of its life, we'll go and make another block.
You're basically using this Warmstone, which you nicely explained, to turn the intermittent, non-stable wind and solar energy into something that's constant whenever people need it. The Warmstone is you use recycled aluminum plus basalt, which is also abundant and cheap, to put them together. And one thing I didn't quite get is like how it works. It's like when the wind and solar energy heat up the Warmstone and then it's stored in the Warmstone.
So we put electric elements, just like the ones in your oven, we put them inside the material when we make it. So we can just put electricity through these little electric elements and they heat the material up. We put a little vacuum flask around it. So if you think of your thermos flask or your insulated mug goes around there, that keeps the heat in. And generally, we have very, very low losses because you're normally going to charge from the sunshine during the day, and then you're going to use the energy overnight. And so actually the losses are they're a very small part of it. And the way we get the heat out, as I said, we put pipes in this material, and by putting water through the pipes, you can get either hot water or steam out, which is very useful for a large number of industrial processes.
How would you explain this to an 8-year-old?
Okay, so it's really important that we cut the amount of fossil fuels that we're burning. When you go into your supermarket and you buy your food and your drinks, there's a lot of energy that's gone into making them so that you can buy them and they're easy to cook. So this is sort of industry, and you can give heat to industry which doesn't involve burning gas. So the way we do it is we take electricity from a wind farm or from solar. Obviously, this is going up and down all the time as the wind increases or the sun rises and sets. We take that electricity, and if you think about your oven, you'll have these little things inside, electric elements, they're called, that heat it up. We do the same thing with this material, which we call Warmstone. We make big, heavy blocks of this material, and we heat them up so that they're very hot using the electricity from the wind and the solar. These are rocks that we can dig out of the ground, and this is a metal called aluminium that's used in lots of things, from aeroplanes to your car, in cars. And the nice thing about aluminium is you can recycle it. So you can take old car engines, and when you heat them up, it turns into a liquid. And so it's a bit like cooking. We take the rocks, we melt this aluminium, so we heat it up a lot, and we pour it over the rock, and it effectively we allow it to set into a block. Think of it as a very heavy rocky road cookie that we've made by cooking. And this is what we store the heat in. So we can take electricity when it's sunny and when it's windy. We can make this block really hot. And then when the factory that we want to supply heat to needs it, we get the heat from this block into the factory.
It's like a cookie. So you make it with like chocolate inside. And then you can put it away because you don't necessarily need to eat it. So, but then you can always heat it up in the oven. And then it's toasted and hot and delicious when you need it. You need the energy.
That's right. So this is a cookie. I'm not going to have a go biting it, but it does the same thing.
Yes, that's perfect for 8-year-old. Great. Okay. So the next section is you answer the question from the previous guest. Her question is, what is the biggest challenge in your technology? Okay, the biggest challenge in our technology is,
so it's always scaling. So when you develop bits of equipment that are big and large, they take time to develop. You need to put them on people's sites to prove it. We're at the very early stage of our journey. We've made lots of small units that have worked really well, reliably in the field. We're now making a bigger unit that we need to put onto a site, and all of this takes time. So 5 years from now, assuming that everybody's happy, their technology they regard as proven, you can sell it very easily. But it's always very difficult to get the first sales and to get them quickly. There is a phrase for the stage we're at, which is not very nice, but called the Valley of Death.
You would just jump through the Valley of Death.
We're going to soar across the Valley of Death.
Yes, great. So if you can leave a question.
Can I leave the same question for the next guest? It's a great question.
Well, yeah, you can, but think of another one. Maybe because if next guest, they don't really
Okay, what's the biggest challenge to your business?
Okay. So this
it is a great question. It's a great question.
Yeah, that's a great question. Yeah. This is James from Caldera. Really, really happy to have you. I hope you enjoyed this episode.
Lydia, thank you.
Thank you.
Expressed by our guests are their own and do not necessarily reflect the official position of Bite-Size Climate Tech. We thank our guests for sharing their insights and experiences, and we thank you, our listeners, for joining us on this journey. Until next time.